Hello everyone, welcome back to another video of Target Pharma 360-degree examination. So dear students, as you all know, this newsly series is basically designed for the examinations for all the pharma competitive examinations, like it could be a ZPAT examination, NIPER, Pharmacist, DI, each and every examinations. And in today's class, we are going to have questions from the organic chemistry. And the topic of today's video is going to be nomenclature and classification. So basically we are going to see the 20 MCQ questions from these topics, and let's get started. What are basically the questions from these topics that are asked in your previous examinations, as well as it could be any of the examinations where these kind of questions can be asked. Now the first question is, in the IUPAC name of a compound containing both an isocyanide and an alcohol group, which group will receive the suffix? So there is a functional group like isocyanide, that is NC, and an alcohol group. Both are present in a structure which will be receiving the suffix. It means this is a direct question regarding the priority of functional groups. Now, as we all know, the highest priority is given to the carboxylic, then sulfonic acids, and later on we are having esters. Let's suppose we are having ester, acid halides, okay, acid halide, it could be chloride, bromide, or anyone. Acid halide. After that we are having acid amides, and then we are having aldehyde, oh my bad, amide, and then we are having C triple bond N, that is nitrile, and after we are having N double bond C, and then we are having CHO, C double bond O, that is ketone groups, and later on we are having alcohol. So we can clearly see like alcohol's priority is lower than NC, that is also known as isocyanide group. So the suffix will be from the isocyanide group. So alcohol will not be receiving the suffix, but it will be receiving the what prefix, that is hydroxy. So this is correct, but we have been asked about the suffix. Isocyanide will be receiving suffix as carbylamine. No, carbylamine will be carbylamine, and isocyano. Isocyano is prefix word. Isocyano is a prefix for the naming of isocyanide, but carbylamine is the suffix name for isocyanide group. So yes, the right answer will be C. C is the right answer. This is the priority table, and we can see NC, that will be having prefix name as isocyano and suffix name it is like carbylamine, and for the CN, that is nitrile, will be given as its suffix name and cyano as its prefix name. Moving to the next question, what is the IUPAC name of the following compound? So what will be the IUPAC name of this structure? It's a bicyclic structure. It is having bridgeheads. And now we can see like the numbering can be started from either this carbon or this carbon, these fused carbons. So since we are having same chains on both the sides, so if this is first position, then it could be second, third, fourth, and fifth, sixth. So total we are having 6 carbon. So it could not be heptane, octane, no. Only one of the option we are getting, that is having the word root of hexane, that is 6 carbon. And for the case of bicyclic system, we basically name it as, first of all, bicyclo, with both the side chains, how many carbons are present on that particular side chain. So we are having 2 here, 2 on this side, so 2, 2, and 0 on this side. In the third chain we are having no any carbon, so that will be bicyclo 2, 2, 0. It should be placed in the descending fashion, so 2, 2, 0, and hexane. So yes, A will be the right answer. A will be the correct answer for this question. The right answer is A, and here is some of the other examples as well given. Moving to the next question, we are having IUPAC name of the given structure. It's a spiro structure. Okay, it's a spiro structure. The basic difference between a bicyclic system and a spiro system is like the spiro will be having a 4-degree carbon, that is a carbon that is directly connected with a 4 carbons, while in the bicyclic bridge system we are having 2 carbons that are basically having 3 degrees, 3-degree carbon we are getting. And here both the rings are fused around a single carbon, while in the case of bridged ring system the 2 rings are fused around 2 carbons. So how their nomenclature has been done? Always numbering is started from the shorter size of ring, shorter ring size. So we are having shorter ring here, while this is a larger ring. So either the numbering can be started from this position or from this position. Since there is no any substitution is present, so we can start, let's suppose this is first, this is second, this is third. Now we are having fourth. Now fifth can be given either to this, either to this, depends on you. So fifth, sixth, seventh, eighth. Total number of carbons is 8. So we will be having word root of octane. Okay, all of them are having octane. Later on, we will be having the ring sizes. There are 2 rings. So 1, 2, 3. Here 3 carbons are present in this ring, and 1, 2, 3, 4. In this ring we are having 4 carbons. We skip the spiro. This is known as spiro center. This is called as spiro center. We skip the spiro center, and later we see like here we are having just 3 carbons, and in this ring we are having 4 carbons. So 3 and 4 carbons. So spiro. First of all, should be writing the smaller ring size, that is of 3 carbon. Later on, the 4 carbon ring size. So spiro 3, 4 octane. 3, 6 no, 4, 3 no, 4, 5 no. Only A will be the right answer. Spiro 3 and 4 octane. Spiro 3, 4 octane. In the case of spiro, always a smaller ring size is been preferred, and here we write the numericals as in ascending fashion. Smaller first, then the larger one. Match the following. Here we are having some functional groups and their prefixes. Prefixes, okay. So C double bond O. C double bond is prefixed as oxo group. Okay, oxo group. Okay, here we are having first Q. Okay, eliminated. All of the options gets eliminated. OH is hydroxy. Okay. So P, correct. NH2 as amino. Okay, correct. And 4, that is CHO as formyl. True. So all are matched in C option. So the right answer in this question will be C. Right will be C. Match the following. Here we are having compound name and their formula. So we are having N-butane, that is normal butane, straight chain butane. So continue 4 carbon chains. Okay. So here in the 4R we can see 1, 2, 3, 4 carbons. So N-butane. Okay. So first will be matched with R. Okay. Wrong. Each of the options gets eliminated by just a single pairing. Isobutane, that is a butane which is having 3 carbon and 1 substitution. Like this is having some structure like this. So this is a isobutane. That is isobutane. We are having CH3, CH3. Okay, so Q. 2 is matched with Q. Neopentane. The same, like if we skip this H and we are having CH3, this is neopentane. Now this structure becomes neopentane. So CH3C and we are having substitutions, correct? P and N-pentane, that is normal pentane, 5 carbon chains. Okay, so S and we are having P. Okay, so A is the right answer. A will be the correct answer for this. The right answer is A. Find the odd one among the following. What is the odd option given? Like we are having alicyclic, it's a cyclic compound without aromatic characters. Heterocyclic compounds, it's also a cyclic compound. It could be aromatic or no, like non-aromatic. And branched chain compounds. Okay, so this is a chain compound, correct? Aromatic compound. Okay, aromatic compounds are cyclic. This heterocyclic, clearly saying like these are cyclic compounds. Alicyclic are also cyclic, while this branched chain are chain compounds. This is a chain compound. Okay, so the right answer will be C. Like this is an odd one. All of them are cyclic except the C option. So yes, the C will be the correct answer for this question. C will be the right answer. This is about the classifications. What is the proper IUPAC name for this structure? So we are having a structure that is having 2 double bonds and some of the branchings as well. So here we can see like in this structure we are having a double bond, that is alkene groups. Now if we count this from here 1, 2, 3, 4, 5, 6, 7, so we will getting 7 carbon, longest carbon chain, but we have a substitution of double bonds. And if we count 1, 2, 3, 4, 5, 6, we are getting longest carbon chain of 6 carbons, but we are having a shorter chain now. So which change or which word root to be used here? Always remember, if there are any of the functional group, we always give priority to the functional groups. Later on the double bonds or triple bonds, and then we are having the longest carbon chains. Then we are preferring the single. If it is saturated, then only we are going to the highest number of carbon for our word root decide. But here the word root is decided by this chain, since it is having double bond. So first will be given to this carbon, second, third, fourth, fifth, sixth, since the double bond arises here at the first position only. So we are having a propenyl group at third carbon. So 3 propyl, 4, go wrong, 3 propyl. We are having 6 carbon as hex, and we are getting 1 and 4 diene. 1 and 4 diene. So yes, A is the right answer. A is the right answer for this question. A will be the right answer. Find the odd one among the following, which is again a odd one. Alicyclic, that is also a cyclic compound. Heterocyclic compound, okay, cyclic compound. Aromatic compound, okay, again a cyclic compound, but branch chain, it's a chain compound. So this is the odd one. So that's why this will be the correct answer. Okay, I guess this is a repeated question. C will be the right answer. Correct nomenclature for the following bridged bicyclic ring system is. So correct nomenclature for the following bridged bicyclic. Bridged bicyclic. Again, it's a bridged ring system. We are having a bridge ring system. So we are having a bridge ring system. Numbering will be started from the bridgehead positions. These are known as bridgeheads. So either this can be number 1 or this can be number 1. Again, there is no any branching of functional group or any other. So we can start numbering from any of the bridgehead position. Now always, for the case of bridgehead, we start numbering from the larger chain side. We are having 3 chains, 1, 2 and 3. Always start from the larger chain. So we are getting 2, 3, 4, 5, 6. Okay, now we are having 3 carbon, 1 carbon, so 7, 8, 9 and then we will be getting 10 here. So total carbons are 10, so decane, okay, correct. Now bicyclo, we write bicyclo, and after bicyclo we have to write down 3 numericals, 3 numeric digits, and these digits are which of the chain is having the highest number. So that must be following the descending fashion. First of all, we will be putting the largest carbon chain, then the smaller, and then the smallest one. Here we are having 1, 2, 3, 4 carbon. So this chain is having 4 carbons. This chain is having 1, 2, 3 carbons. And the inner one is having just a single carbon, that is here. So we are having 4 carbon chains, then 3, then 1. 4, 3, 1 decane. And this is all about the nomenclature of the bridge ring system. So we are having bicyclo 4, 3, 1 decane. Here we are getting the 4, 3, 1 decane. 4, 3, 1 decane. So C is the right answer. C will be the correct answer for such kind of questions. Groups of atoms that can occur within organic molecules are called. Okay, so here we are asked about the groups. And these groups are basically those that decides the chemical nature of that particular compounds. So these groups are known as cyclic compounds, functional group, homologous series, or none of the above. So these groups are having the valid reason to decide the chemical natures of those particular compounds, whom they are attacked, whom they are attached. So B option will be the right answer, that these groups are known as functional groups and they decide the chemical natures of those particular structures. What is the UPSC name of the following compound? So here we are having again a bridge ring system. These are the bridge heads. No branching present again here. So we'll be numbering either 1, 2, 3, 4, 5, 6, 7, 8. Now you can simply see all the chains are having 2 carbons. So we can start from any of them. So it's a bicyclic system. Total carbons are 8. So octane. Okay, so this is wrong. Bicyclo. 2, 2, 2. Each of the chain is having 2 carbons. 1, 2, 1, 2 and 1, 2. So bicyclo 2, 2, 2 octane. Bicyclo 2, 2, 2 octane. So this is wrong. This is 0, wrong. Bicyclo 2, 2, 2 octane will be the right answer again. The IUPAC name of the compound. Here we are having a question that is having CH2 that is attached with the chlorine. Then CS that is having a CS3 substitution and a CS3. So this is something like this. Okay, so the first position, this one, this is the second, this is the third. At first we are having chloro, at 2 we are having methyl. This starts with M, this starts with C. Always follow the alphabetical order. So 1 chloro, 2 methyl and propane. 1 chloro, 2 methyl. 1 chloro, 2 methyl propane, since it's a 3 carbon chain, longest carbon chain. B is the right answer for this question. What is the IUPAC name of the following compound? Okay, so here we are having a structure that is having a carboxylic group. Okay, we are having a hydroxy, that is OH group, and we are having a NH2, that is amino group. It starts with M, this starts with H. Since it's in it must be present in the prefix. Like we are having the highest priority to this carboxylic carbon, that will be in the form of oic acid. So we are having, first of all, 2 amino. Since amino A starts earlier, 2 amino. Amino is present at 2 positions. So this is wrong. It could be any of them. Now. Hydroxy, that is present on the 1, 2, 3. Third position, we are having hydroxy group. So propane, wrong. This is wrong. 2 amino 3 hydroxy, 2 amino 3 hydroxy. Now we are having 1, 2, 3, 3 carbon chain. So propanoic acid. So here we are having butanoic. So this is also wrong. The correct answer is in the D. D option is right for this question. D will be the correct answer. Okay. Principal functional groups is made on the basis of the following order. Okay, so here again we are having just a priority sequence order. Always we give priority to the carboxylic. Okay, here the carboxylic is at the least position, least. Again, carboxylic is having lower priority than aldehyde ketones. This is wrong. This is wrong. Sulfonic, aldehyde, carboxylic, then ketone. This is also wrong. Priority order is like carboxylic, sulfonic. Then we are having anhydride, ester, acid halide, amide, cyanide, isocyanide. Then we are having aldehyde and ketones. So the right answer is A. In the given 4 options, the correct answer is A option. Match the following. So here we are having functional groups and their suffixes. So COOH is matched as oic acid. So first will be matched as P. This is wrong. This is wrong. CN, since we have to decide the suffixes. So CN is having prefix as cyno, while nitrile as suffix. So suffix will be nitrile. Okay. So that is Q. NC, that is having carbylamine. Okay, so I guess they are all just straighter ones. CHO is having matching with the al. Yes, correct. It's aldehyde, and in the prefix it is having formyl, and in the suffix it is having al group. So A is the right answer. A is the right answer for these questions. IUPAC name of the given structures. What is the IUPAC? Again, it's a spiro. Always it starts from the shorter size of the ring. 1, 2, 3. And we are having 4. Now we can move any of the directions. Let's suppose 5, 6, 7, 8, 9. We are having 9 carbon non-N. So this is wrong. This is wrong. We are having 1, 2, 3 carbon chain in this ring. 1, 2, 3, 4, 5 in this ring. So we are having 3, 5. Spiro 3, 5. So this is wrong. Spiro 3, 5. Total 9 carbons are present. So word root as non-N. So Spiro 3, 5. Non-N is the right answer. Which of the following is an alicyclic compound? Alicyclic means it is not an aromatic compound, it is just a cyclic one. Benzene, you know that yes, benzene is an aromatic structure. Benzene is an aromatic structure. Furane again is an aromatic structure. Furane again is a aromatic structure. Aromatic structure. Hexane, it's a branch, it's a chain structure. It's a chain, it is not cyclic. Chain, not cyclic. Okay, this is not cyclic one. So this cannot be our answer. Now cyclohexane. Cyclohexane is just this one. So yes, cyclohexane is a cyclic structure and it's a alicyclic, like aliphatic kind of cyclic structure. So yes, C is the right answer. C will be the correct option for this question. The IUPAC name of tartaric acid. Tartaric acid is having IUPAC named as COOH, the structure. First of all, look at the structure of the tartaric acid. We are having OH, H, OH, H. Let's suppose we are having this structure as tartaric acid. And now we are having 1, 2, 3, 4. We are having 4 carbons, so but. And we are having hydroxy groups as present as 2, 3 dihydroxy. 2, 3 dihydroxy. Total we are having 4 carbons, so butane. And at 1 and 4th position, 1, 4 dioic acid. We are having dioic acid. 1, 4 dioic acid. So let's see where this correct option is having. 2, 3 dihydroxy. 2, 3, 2, 3. This is wrong. This is wrong. 2, 3 dihydroxy. 2, 3 dihydroxy. Butane. Okay. And 1, 4 dioic acid. This is just 4 butanoic acid. This is also wrong. So right answer is A. A is the correct option. A will be the right answer. Okay, this is the case for tartaric acid, and this question was asked in the GPAT examination on the 2024 GPAT examinations. What is the IUPAC name of the following compound? Again, it's a spiro system or a bridge ring system. Just tell me, it's a bridge ring system. Why? 2 rings are basically fused at 2 carbons. 2 rings are basically fused at 2 carbons. So it's a bridge ring system. These are bridgeheads. Now we can start numbering from either this or this. Let's suppose this is one. Now we are having all the chains, all the cyclic rings just of 1 carbons. So you can start from any of them. 1, 2, 3, 4, 5. Total we are having 5 carbons. So it will be having a pentane, and it's a bicyclo 1 1 1, bicyclo 1 1 1 pentane. A is the right option. A will be the correct option for this question. Correct option will be A. Next question we are having, which of the following is the correct IUPAC name for? Which of the following is the correct IUPAC name? So we are having a cyclohexyl group, we are having a ketone group, and we are having a double bond. So we start numbering from this is first, second, third, fourth, fifth. Since we start numbering it from this side, then we are also getting the C double bond at third. If you start from this, then we are also getting the C double bond at first position, as the highest priority functional group is ketone here. So we are having cyclohexyl group. Cyclohexyl group present at the first position. So one cyclohexyl, one cyclohexyl, one cyclohexyl, one cyclohexyl. Okay, this is not phenyl. Phenyl must be having a benzene ring structure. Then we are having 5 carbon chain. So pent, 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 pent. Okay, and we are having pent 1-ene, 1-ene. So this is wrong. Pent 1-ene, pent 1-ene, and 3-one, not 2-one. The right answer is A. A will be the right answer. A is the correct option for this question, and this is the right answer for this question. And this is all about 20 questions from the topic classification and nomenclature, and this was our series that is named as Target Pharma 360-degree, and I hope this series will be beneficial for all of the aspirants that are preparing for any kind of pharma competitive examinations. And stay connected with us. I see you again. Thank you so much, everyone.